Assalamu alaikum. Bismillahirrahmanirrahim. We are discussing Juniper certification. Is JNCIS-SP. That's basically service provider track, specialist course. Last day we have discussed graceful restart and BFD. Today we discuss GRES NSR and Unified ISSU. GRES means graceful routing engine switchover, and NSR means non-stop routing, and unified ISSU means in-service software upgrade. That means when you have multiple routing engine, you can enable those protocol to make sure failover. That is the main reason. We will discuss one by one. Okay, first one is graceful routing engine switchover. And you see the picture. You have one router that have multiple routing engine 0 and routing engine 1. By default, routing engine 0 will be the primary and routing engine 1 will be the backup or secondary routing engine. So when you consider redundant, if one routing engine failed, another engine will take over. In that case, you have to enable. You have multiple routing engine, but you yet not enable graceful routing engine switchover. In that case, if one routing engine failed, your traffic will be switched over to another routing engine, but your all protocol will be goes down and up. So if you enable graceful routing engine switchover in your primary routing engine, then if your primary routing engine goes down or sense any fault, every traffic will be forward to or switch over to backup routing engine without any interruption. Okay, so that is the main reason to enable the graceful routing engine switchover. Say here, when graceful routing engine switchover GRES is enabled, interface and kernel information is preserved, so the traffic forwarding is not interrupted. That is the main reason to enable GRES or graceful routing engine switchover. So that is the main reason, and you can get the comparison between when you enable the GRES or when you disable the GRES or not enable the GRES. Okay, without GRES, packet forwarding engine is restart. All hardware and interfaces are discovered by the new primary routing engine. The new primary routing engine restart routing protocol process. That means RPD. And all adjacency are aware of the physical changes, interface alarms, and routing changes. That means everything will be restarted. So if everything will be restarted, it will take time to forward traffic. That is the big challenge. Okay. If you enable the GRES, that is it will take very short time to switch over traffic from one routing engine to another routing engine. Okay. So here is another picture of switch over traffic. And you can check which routing engine is master routing engine and which one is the backup routing engine. Just press the command show chassis routing engine. Show chassis routing engine show you which one is the master and which one is the backup routing engine. Okay. So this is the configuration of a routing engine. Consider there is multiple management interface. See here, FXP0 for RE1, there is one address. RE1 and RE0 have a management interface and that have another IP address. And this is the basically routing engine switch over primary configuration. Okay, if one goes down, like 51 goes down, 50 will be up, or if 50 goes down, 51 will be up automatically. So first, you create the group, routing engine one group. In routing engine one group, your management interface and hostname and backup router command will be under RE1, and this is one group. Another group is RE0. You can set any name, but normally we set RE0 and RE1, routing engine 0, routing engine 1. Under routing engine 0, you have to consider management interface and management interface IP address, hostname, and backup router. Okay. And lastly, you have to apply the groups uh, uh, in RE0 and RE1. This is the process or step to configure routing engine 1 and routing engine 0. This is the total configuration in one shot. So, and you have to enable the graceful switch offer. When you configure routing engine, multiple routing engine, and apply in groups, when you go to the chassis option, you have got one warning: graceful switch over is enabled. Commit synchronize should be used to commit complete. So, not when you GRES enabled, graceful switch over automatically enabled. Okay. Then second option is you have to configure commit synchronize. Commit synchronize means consider routing engine. You just press commit. Your all configuration is committed. That means your all candidate configuration goes to active configuration. Your all candidate configuration goes to in active configuration. So if you if you commit in your primary routing engine, so your configuration will be stored in primary routing engine. If you want your configuration will be go secondary routing engine, keep in primary routing engine. In that case, we have to configure commit synchronize. So commit synchronize enable this. Your active configuration will be available in primary routing engine, also in secondary routing engine. So this is the reason to configure commit synchronize. So how to set the commit synchronize? Just you are in master routing engine and set the command set system commit synchronize. This is the command to enable commit synchronize. Okay, another operation of graceful routing engine switch over. So say here, by default, RE0 assumes the primary role, whereas RE1 assumes the backup role. This is the default. Okay. Keep alive are sent over an internal link. In that case, RE0 and RE1 communicate with each other. When anyone failed, then others will take the responsibility. Okay. So this is the summary of graceful routing engine switch over operation. So first one grace is configured and the RE are synchronized, keep alive are exchanged. Okay. When you configure grace, then RE will be synchronized and keep alive will be exchanged. First one. Second one, if the backup RE does not receive and keep alive from the primary routing engine, typically after 2 seconds, it determines that the primary array has failed and takes the primary role. That means it communicates within 2 seconds. Within 2 seconds, the interval is keep alive interval is 2 seconds. There is very little time. Okay. The packet forwarding engine seamlessly disconnects from the old primary routing engine, typically RE0, and reconnects the new primary routing engine, that means RE1. So it take the switch over time is very little when you configure GRES. The new primary routing engine and packet forwarding engine synchronized, after which the new primary hurry and send state update message to the packet forwarding engine as needed. So in that case, the summary is the primary routing engine and secondary or backup routing engine always communicate with each other. If one fails, uh, your traffic will automatically switch over to the backup routing engine without any interruption. And when your traffic is goes to the backup routing engine, their packet forwarding engine also synchronize with that routing engine also. Uh, if you want to enable redundancy, you can set as is redundancy routing engine. Okay. And if you want to switch over one routing engine to another routing engine, you can press the command request chassis routing engine master. You can release or you can switch. Okay, you can release or you can switch. Just for test, your backup routing engine is working or not. You set commit synchronize. You commit the command in master routing engine. You want to check the configuration is goes to backup routing engine or not. So in that case, you can switch over one routing engine to another routing engine. Okay. So uh, how to configure graceful switchover? Just set chassis redundancy graceful switchover. Graceful switchover. You will have to configure this under chassis. Under chassis. Monitoring graceful routing engine switchover. How to monitor? You configured the graceful routing engine switchover. Show system switchover. Show system switchover. You will get show system services, snapshot, software, statistics, storage. Nothing. Nothing here. But see here in backup routing engine, here you are in master routing engine. Okay. When you are in master routing engine, you cannot verify GRES state details on the primary routing engine. The acquired command is only available on the backup routing engine. So switch over to backup routing engine and press the command show system switch over. In backup routing engine, show you the details. Graceful switchover is on or not. Okay. So this command is only available in backup routing engine, show system switchover, not available in master routing engine. So see here, when graceful switchover is on, configuration database synchronize in both routing engine, primary and backup. Kernel database information is updated between two routing engine. And another consideration is you have to maintain same software version. You have to maintain same software version. Otherwise, you will get error. Okay. Second one, non-stop active routing. Non-stop active routing. Here, if your router have multiple routing engine, in that case, you enable non-stop active routing. Otherwise, no need. No need to enable non-stop active routing. Okay. See here, there is multiple routing engine. So in that case, you can consider non-stop active routing. So what is the function of non-stop active routing? See here, non-stop active routing enables a primary role changes to occur without alerting peer nodes of that change. That means graceful routing engine switch over, you have to enable grace. When you enable non-stop active routing, firstly, you have to enable the GRES. Preserves routing information and protocol session. If you enable non-stop active routing, your routing information and protocol session is preserved. When one have if one goes down, another protocol information switch over to another routing engine automatically. Okay, and they are communicating with this other routing engine will communicating with this other. So trigger the routing engine to run the same version of GNCIS. You have to maintain this one. Okay, same version. Preserves state information during switchover events not supported on all Junos devices. Basically, those are multiple routing engine. Those model contain multiple routing engine. Those devices basically support this feature, non-stop active routing and GRES. So how to enable the NSR, that means non-stop active routing? Just go to the routing option section. Under routing option section, set non-stop routing. Set the command non-stop routing. If you set the command non-stop routing, your NSR is enabled on that router. Okay. So how to enable GRES? Just under chassis, set redundancy graceful switch over. And last one, set system commit. You have to configure set system commit. And last one is synchronize. Set system commit, synchronize. So there is three command you have to enable. For non-stop routing, set routing options, non-stop routing. Then for GRES, set chassis redundancy graceful switch over. For configuration, synchronization, for configuration synchronization in both routing engine, you have to set system commit synchronize. There are three commands. Monitoring NSR. If you want to monitor NSR, you have to press the command show task replication. Show task replication show you protocol is synchronized or not. Like say here, stateful replication enable, RE mode master, protocol WSPF, synchronization status complete. BGP synchronization status complete. Okay. So if you not enable GRES, this will not happen. You have to enable GRES. So three things. One thing is you have to enable GRES under chassis. You have to enable NSR under routing options, and you have to set commit synchronize. This will work perfectly. Okay. Unified ISSU. Unified ISSU means basically this protocol or this method will be used when you have multiple routing engine. So one is primary routing engine, another is backup routing engine. So this protocol basically, this method basically used when you update your software version, when you update your router software version. Just if you consider manually, you update software version in primary routing engine, then switch over to backup routing engine and manually update the backup routing engine software version. This is the manual process. Okay, this is the manual process. So if you want, you just update software version in primary routing engine, your secondary routing engine software automatically updated, will be updated automatically. In that case, you have to enable ISSU. Okay, so this is the step unified in service software upgrade. First one is enables you to upgrade between two different Junos OS release with no disruption on the control plane. Eliminates network downtime during software image upgrades. So when you upgrade your software, traffic will be traveled normally, no issue. Okay. Reduce operating cost while delivering higher service levels, support fast implementation and EPSR. So this is the step performing a unified ISSU. So first step is enable graceful routing engine switch over. First, you have to enable GRES, then non-stop active routing, then NSR, and verify that routing engine and protocol are synchronized. So first one is you have to enable GRES and non-stop routing before starting ISSU. Second one is verify that the primary and backup engines are running the same software version. So you have to check existing version also. Third one is download the new software package from the Juniper Network support website and the copy the package to the router. So download your respective software version from Juniper website and upload to your router master routing engine and press the command request system software in service upgrade command on the primary array, that means master routing engine. So issue the command in master routing engine. Master routing engine software will be upgraded first, and after software upgrade in master routing engine, then secondary and second software update will be in next software update will be performed in secondary routing engine. So this is the show command to checking in service software upgrade. If the unified ISSU procedure stops progressing, complete the steps. That means open a new session on the primary routing engine. If your attempt is failed, in that case, open a new session on the primary routing engine. Issue the request system software abort in service upgrade. Just press here abort and replace. I use here ecosystem software in service upgrade, and I use here ecosystem software about in service upgrade, and check the existing router session to verify that the upgrade has been aborted. Normally will not get any error if this condition, all condition is smashed. You enable GRES, you enable NSR, protocol synchronization is happened, your primary backup routing is software version same. Okay, in that case, they will not get any error. So that's all for today. So any query about GRES, NSR, and unified ISSU?
Yes, I have few confusion about GRES. Uh, in GRES, we have two routing engine. One is primary, another one is backup, right? Uh, in that case, I have confusion. When the whole physical data will be down or will be disturbed, then will be disturbed. That time that uh, traffic will be shipped in backup routing engine. Is this like that or something? If routing engine 0 is restored, then routing engine 1 will be backup routing engine will be restored.
Could you repeat your question?
Actually, uh, for graceful routing engine, we have two routing engine, right? One is
Right.
primary, another one is backup. If primary
Uh-huh.
goes down, then backup will be down. In that case, I had question that if the whole physical router will be down, will be restored, whole physical router will be restored.
Oh,
Then
physical
what
router goes to restart event.
restored?
Okay.
And then what will happen?
In that
Is
case, they are just normally rebooted, and primary routing engine will be take the responsibility.
okay. That means in that time backup routing engine will not be enabled. A specific routing engine, primary routing engine.
Backup routing will be enabled, but the master routing engine take the responsibility of forwarding traffic. Okay.
Okay, okay, okay. And what is NSR? Could you please tell me?
Primary will be primary in every time. Okay.
Okay, okay.
If
Uh,
if any issue happened in primary routing engine, it may be kernel failed or kernel corrupted, or it can be any other issue, then they will switch over to backup. Okay. Otherwise not.
okay, okay.
Restart event is
If,
normal event, right?
okay. Is there any way to restart a specific routing engine?
Mm-hmm.
Is there any way to restart if I, for troubleshoot purpose, if I restart
Mhm, of course, of
yeah,
course. I already show you. You just press command request a chassis, and you will get multiple option. You can switch one routing engine to another routing engine with the command keyword is switch, and you can use the acquire command to stay in routing engine. Okay,
okay, okay, got it, got it.
just for checking.
Could you please repeat it again? Actual what is NSR?
This is the command I show you, and master. Where is maybe in GRES Swiss over I see here. Request access routing engine master.
Master. That is
So
fine.
after master, you can acquire. Acquire means attempt to become master routing engine. That means you you want to say I'm in I'm in backup routing engine. So I want to say this will be the master. This will be the master. In that case, acquire. Acquire means attempt to become master routing engine. Okay. This
Okay, okay.
will be the master routing engine.
Master.
Oh, another one is release. Request that other routing engine become master. So if I want to hand over my mastership to backup routing engine, in that case, I can use release command. So, and last one is switch. If you want to switch from one like primary routing engine to backup routing engine, or backup routing engine to my primary routing engine, you can use the switch command just for toggle.
Okay, okay, okay.
Okay.
Got it. What is NSR? Could you please explain actually? Uh,
Mm-hmm.
what is NSR? What is the actual advantage of NSR? Is it good for me to
NSR.
repeat it? Yes.
Actual advantage of NSR is this is basically when one routing engine failed. There is multiple protocol is running in your router, right? Like WSPF, like PGP. Okay. So in
Yeah.
that case, if one routing engine failed, your protocol will be failed. Correct?
Yeah.
Okay, so if one routing engine just communicating with another routing engine, respect to protocol, in respect to protocol, that means if your routing engine goes down, your protocol will communicate. Just immediately shift your protocol information to another routing engine. So your packet forwarding engine will be uninterrupted. That is the main advantage of NSR, non-stop routing.
Okay, okay, got
Okay.
it.
Okay. Okay. Thank you. So